Okay, so anti-Mac. Explain.
I just don't like their operating system. I think it limits you.
Okay, in what way?
Just like the inner workings of how you can. I don't know. I prefer Windows. Just the ability to like schedule tasks and the more availability of applications.
Okay, more availability of applications is going to be obviously hard to argue against. Um,
Also, price.
Why not just
I think
learn
they charge
to
a
use
lot for
operating
their operating system.
well, the operating system's free. They charge a lot for their machines. Now,
But their machines aren't worth the price that they're.
yeah, so you typically what I've told people is the right machine to get as a technologist, again, if you can afford it, is a MacBook Pro and then dual boot Windows on it, or if you do VMware or something like that and have both, because you're right, there are times when you need the Windows side of things. Um, Now, obviously, if you're a PC gamer, you get a Windows machine. And if you're a super geeky person and you really needed to do some of the Mac stuff, so really the only thing you have to have Mac for, let's say, is iOS development or something like that. You can pretty much pull everything else off on a PC. And even on a PC, you can do one of the projects like Hackintosh or something like that. Technically, I think you're outside of acceptable use on the software, but you're also probably not going to get the best end user experience, but you are getting a less expensive end user experience. Um, with that in mind, I used to make the argument that you could carry one machine. You would with a Mac, you would get two machines for the price of 1.7. So you're actually getting a 30% discount off of buying two physical machines. But they have been bumping those prices a little bit lately, so it might be two machines for the price of two or 2.1 at this point. But yeah, I mean, I really can't necessarily argue with that. I mean, I think most people would probably, if you really inspected them, would probably say the Macs are built better, but do they need to be built that well? Like, is it for a computer? Is it worth paying an extra grand for this premium build quality when you can kind of get the same parts for a lot less and have acceptable build quality?
They're also really restrictive on like what data rights.
Yeah.
That's Apple. That's not Mac. That's
Mhm.
just Apple in general.
They
Yeah.
solder everything, so you can't.
But that sucks.
Like
Well, you're right. Yeah.
you used to be able to upgrade Macs, and then
You used to be able to upgrade battery and RAM.
yeah.
I guess you could technically upgrade the other stuff for a while, but they would make it convenient, user upgradable battery, RAM, and
Hard drive.
hard drive ish. Yeah, I mean there was usually an extra panel you had to kind of get through, but you're not right. I mean, you're not wrong. Rather, you're not wrong in that by getting this build quality, by getting things super super thin and things like that, they've had to take all this stuff out. The way they can get the battery life to what they have the Macs at is if you look inside the thing, the entire computer is like this. Because everything's soldered together. There's no mechanical hard drive. There's no interfaces. It's just soldered. It's all part of it. And then the entire rest of the thing is battery. And they even get extra battery out of it because it's not a removable battery. So, all the little mechanics that would allow, the little, interfacing that would allow you to pop a battery out and put a battery in, that's gone. So that's space where you can put more battery is the punchline. So it's a trade-off. You get the... So I don't disagree with the premise. What I don't like is when folks just have a kind of a philosophical, well, Apple's business practices are bad, which I would probably say they are, but no worse than insert big company name here. I mean, it's just the nature of that. Yeah, I don't know. Frankly, the big reason if I didn't use Mac, I'd use Linux. I don't dislike Windows. I mean, whatever's the right tool for the job is fine. But I spend quite a bit of time at the terminal, so the Mac gives me convenient access to a Unix terminal. But I grew up with that, so that's very comfortable for me. So Mac gives me my most convenient interface to software that will accurately plug into the business world and export stuff for the Windows side. I think that's probably the fairest statement. Where I think if you were on Linux too often, I mean, technically they have like Office equivalents and things like that. But I mean, if you're exporting PDFs and Word documents and things like that, I wouldn't trust it as much coming off of an open source Linux package as probably the Apple stuff. I mean, I wouldn't trust it as much as real Office on Windows. But yeah, so I think there's something to be said for some of it, as long as it's not just a philosophical, I hate Apple because they're Apple. Because that just seems to be just such a, but Apple did that for years. Well, Apple fanboys did that for years, right? Like, I hate insert not Apple just because they're not Apple. And that was back when the Apple OS sucked. The smartest thing they ever did was steal Unix and put a fluffy front end on it, and now you got a stable operating system that's actually solid. Gave me my Unix terminal. I had a friend of mine one time talk about kind of the usability of Mac OS. I think most Mac people will say, well, Mac OS is so much easier to use, but I would kind of fall in your category. Less so now, although they sort of brought the start menu back. But, I mean, at least with Windows 95, Windows 7, I mean, where do you start? You click Start. That's where the stuff is. If you're sitting out of the desktop of a Mac, what do I do? I mean, there's stuff on the bottom, but there's no words. It's just pictures. Yeah, I don't know that the Mac OS is overly friendly to use. I think if you aren't accustomed to using Spotlight, the Mac OS is actually probably pretty inconvenient to use. I mean, you can open stuff really quickly and things like that if you're used to, the handful of power tools built in the OS, and I think that makes the OS a very powerful OS then. But if you're not accustomed to that, and you got to just flop around until you find the application folder, and then you're going in there and looking for your app.
That's pretty much me.
Spotlight and the Cortana search bar are the same thing, they're just in different corners of the screen.
I don't know.
Yeah.
In second grade, we were using nothing but OS 10, and that was perfectly fine. And up until that point, I hadn't really used computers, so.
Yeah.
I'll give it to them. They have the best trackpad. They have a really good trackpad.
Yeah. But then you also have the folks that are just anti-trackpad.
I think that
My wife would not use. She won't even give it a chance. My wife is she taught me the word, actually. It's called persnickety.
Persnickety people. Can't even say it. Persnickety people, exceptional. Can't say it.
Exceptional.
Jeez. That's Sargento's.
Oh, okay. Yeah.
I can't say it.
My wife likes things the way they are and does not tolerate change very much. She's a COBOL programmer. At her office desk at home, she works remotely for Western Illinois University. She has an old Microsoft Natural keyboard with the split keys. Huh? She will not go away from that. When her previous one started messing up,
those things.
it was a headache to find a replacement. You can't buy them anymore. I think off of some website in Germany or something like that.
You can 3D print those.
Really?
Yeah, I've seen it before. You can 3D print custom.
Yeah, I have.
Oh,
seen,
interesting. But I'm just saying. I mean, that gives you an idea there. I mean, she won't tolerate a keyboard that's not split because that's what she's used to.
Oh, that actually kind of reminds me of.
And that's the way I love her. But I have a couple of minutes of practice with those, training those words, because we've been married for it'll be 20 years in May. But yeah, so as long as some of you, actually probably most of you, who in here is anybody here older than 20?
I'm 23.
23? Oh, 21. Okay, so older than half of you. I've been married to my wife longer than half of you. I've been dating my wife for longer than all of you. You said you're 23. Anybody older than 23? Okay, yeah. So I got all of you age-wise. Yeah, so I'm pretty accustomed to the If she wants a split keyboard, she gets a split keyboard. that's what she gets. She doesn't like trackpad. Yeah, trackpads should be dead. I personally do like the trackpad on the Macs.
Is this like a split keyboard you're talking about? Or no?
Look up Microsoft Natural keyboard. You'll get the look. All right, so let's look at this assignment. How did it go? Oh man, this was his home. This was what he did in class last night. This is a fully functional MIPS emulator for a MIPS CPU. Supports subroutines. Yeah, so like here's assembly language in MIPS.
There's a purple circle around SW there?
Yeah, because I think I was searching for SW down here.
Oh, okay.
I did like the find.
What is that?
Yeah. So this is like a working assembly program that supports I/O and everything. So we wrote that last night.
The most I got out of that was do something.
Well, when you take the 325 class, you'll learn, I think, in undergrad 325, we do ARM assembly. And we write an interpreter like this, but we don't do it in Scheme. We do it in, well, we have previously done it in Android, but I might do it in C or C++ this coming time.
I'd be okay with that.
Hang on, 325 classes.
I want to learn.
Computer organization
Well, I suppose.
and architecture.
So, is that in the spring?
I don't know what it is. I gotta find it. I gotta figure out when it meets. It should. I think it should meet in the spring. So in the spring, you should take 325 and 450 with me.
They both have C in it. So does C sharp.
You can take a full 18.
See, sort of does.
Yeah.
But higher levels and
But with the...
You're paying for 18. Why don't you take 18? Well, doesn't that make sense? You're paying for 18 credit hours. That's, I mean, you pay this tuition, and it's a lot of money, right? And it comes with 18 credit hours included. So to get your money's worth, shouldn't you take 18 credit hours?
My mental health disagrees with that.
Yeah, it's like it's a nothing burger.
My concern is taking 2 living programming classes. at the same
Why?
time.
They're easy.
Yeah, that's not a problem.
Well, it could be, like
Well, this class is harder than
8 hours of
the
programming
other
a day,
classes. Yeah.
You know?
All right.
That
So
sounds like a lot of extra time.
what you meant to say is a lot of extra awesomeness,
It'd be a lot of extra awesomeness.
A lot of extra
and you get to do assembly coding.
I know, that sounds cool.
It is cool.
Is that for the 450 that next year? That
No, 325 is the assembly stuff. 450 is systems programming compiler, so OS level. So in 450, we're going to do some assembly stuff, but we're going to be producing the thing that takes your C++ code and turns it into assembly. This thing in the middle.
I thought we weren't offering 450 anymore.
Oh, I'm offering it.
You're offering it.
Yeah,
This spring?
this spring. I don't know when it's going to be yet, but we're offering it, and it's going to fill. I just said what it is. It's called systems programming. We're going to run it as like
The
a,
most important
So are we
class
gonna
you
do
will
any
ever
C
take.
in there?
huh?
Are we gonna do any C in there?
Yeah, it's going to be C.
So do you recommend we should all take that?
Yes.
All right.
I will cordially require you to take it once I get it on the books.
I'll do
It
it.
is technically required for several of us to take it.
Yeah, it is technically required for several of you. It depends when you came in on the major. Because the old major was required, and the new major it's not required, but it's required.
I'll take it anyway. Even if it's.
All right, so this is what we're doing. Number leaves. This was the assignment.
Yes.
Okay, so write a procedure, number leaves, that takes a bin tree and produces a bin tree that's like the original one, except the contents of the leaves are numbered starting from 0. All right, so here's the function here. So as it bumps into a leaf, it labels that leaf. So this would be what, 0, 1, 2, 3, 4. Okay, so when we come in here, if we think about this from a recursive perspective, we are processing an internal node. An internal node has two subnodes. So this guy is going to operate off of a starting count. This guy requires to know where this guy left off, right? We can't do this unless we know this was a 0 and a 1 and the next dude is 2. So when we process this, we somehow have to get the message back that next guy's 2 before we make that other recursive call. Make sense? A couple ways we can do this. One thing, I'll kind of explain out loud, maybe a harder cool kid way of doing it. And that would be what you can do is with the return value of this, you can kind of do like a cool package thing where you can return the newly built tree with a number and then peel out the number and peel out your tree, keep the tree in a let, then take the number and pass it as your input to the next thing. So you can kind of build almost like a mini object inside of there. You know, say, well, I need to boil down to 2 values. Okay, what do you do? Well, I'm going to put my value I really was doing. I'm going to put the value I need to remember in here, and I'll just return the one value that is the list of that. And then whoever receives that can peel out that number he needs to remember and go ahead and keep this other piece and then just cons it onto the tree that we're building. So that would be, let's call it the cool kid, but probably harder to track way of doing this. Easier way of tracking to do this is when I go through here and I see, okay, I'm processing this guy. So that's my top level tree. Before I can do this guy, I have to know the number of leaves in this guy, right? How many leaves are in here? 2. So that means when I process this guy, the first thing I run into would be a 2. So I can write a function that just counts leaves, does nothing else. He counts leaves. And actually, didn't we already write that?
Did we?
Well, if we didn't, I mean, it's simple to write. We'll just write it real quick. So we'll define count leaves to be a lambda that takes a bin tree as a parameter. All right, and he is, yeah, that's fine. So he is a, we'll ask a question. If tree, not tree, leaf, bin tree, boiled down to 1, found a leaf, otherwise, plus 1, and it must be a, this must be a interior node, which is going to have an rson and an lson, right? So I want to call count leaves on both of those. So I'm going to say plus 1 plus count leaves rson bin tree. Is that my extractor for rson?
Yes.
And count leaves lson bin tree.
Does it matter which?
Oh, and actually, I don't need to do the plus 1. I just need to do this. Plus 1 is taken care of with the recursion. So if I found a leaf, 1, found something. Otherwise, I'm going to return the addition, the sum of counting the leaves of rson and counting the leaves of lson. I guess if we're thinking logically here, we would probably flip lson and rson, but it doesn't matter. Got to count the leaves on both of them. All right, and what does count leaves do? It takes a bin tree, and if it sees a leaf, it boils down to 1. Otherwise, it adds count leaves of lson, rson, so on and so forth. So we're just creating a string of additions ultimately adding up to the number of total leaves we found in a bin tree. Make sense? So our test tree here, where's my test tree? So this guy has 1, 2, 3, 4, 5. So for test tree, this function should return a 5. That's the number of leaves it found. For the LSON of that, it should give me a 2. For the RSON of that, it should give me a 3. That'll allow us to kind of test that. So we'll call count leaves on test tree, like that. And then we'll call count leaves on LSON test tree. We'll call count leaves on RSON of test tree. So this was a 5, a 2, a 3. That's what we should get from our output here. Big money, big money. There's the 5. All right. So questions on that part. We have the ability to count the leaves given a binary tree. So if we go back to this guy here, if I'm going to process the leaves on this guy, I would pass in the current count of 0 and find a 1, or label this a 0, label this a 1. But when I go to process it on this guy, I pass in a count leaves on this guy, which would give you my starting point of 2. That makes sense? That would allow me to label this guy with the 2. And then when I go to process this guy, it would allow me to process it on the count of whatever the current count is, plus count leaves of this guy, which is a 1. So that would take me to a 3, which gets me to a 3 and to a 4. Go ahead.
So no matter how deep the left sun is, you would always process the left sun first and then the right sun? So like if this button,
Correct.
it just keeps going down and then it jumps over to the right sun?
Well, you could
Correct.
decide to do all right and then left. I think the key is to be consistent about it.
Well, for labeling them, you mean? I mean, if you follow the way they did their labeling, they did left and then right.
Right, yeah.
So, no, I said left. Right. But who's on first? No, who was on second? You heard that one? That old?
Yeah.
Next time we're like, yeah.
Yeah.
What's the name of the function? Define
Number leaves.
number leaves. And do I need a helper? Probably. Because I'm going to have to pass in that initial count, right?
Yeah.
So lambda is going to take in a bin tree and call it a curse start. I kind of like that. It's a curse start for that guy. Let me just
Kind of sounds like curse splat.
curse splat. All right, so we'll have this guy be number leaves, and this is a lambda that will take in a bin tree and call number leaves helper bin tree and the initial count of 0. That make sense? All right, so if I'm in here, what am I going to do? Well, I'm going to ask those same questions. If leaf bin tree, so if bin tree is a leaf, then what am I going to do? I'm going to create a leaf with curse start. That's what it boils down to. So I'm replacing whatever number was in the leaf with my label that I'm going to number that guy, the 0, the 1, the 2, the 3, so on and so forth. Else, if it's not a leaf, what am I going to do? Well, I want to call number leaves helper, this dude, and I want to pass it my, so if it's not a leaf, it must be a interior node, right? So actually I'm going to build an interior node here. Interior, is it interior dash node like that?
Yeah.
So I'm going to build an interior node with, what is it called? Contents of? Contents of bin tree. That'll be my label thingy. Okay. And then whatever number leaves helper returns, passing it my else on of bin tree along with a cur start, and then number leaves helper, passing it arson of bin tree along with plus cur start, and then what do I call it? Count or count leaves? Count leaves of elson bin tree. Add those together. That will advance my cur start to the correct starting point based on the number of leaves it found on the left side. All right, so now we should be able to give it, is our test tree is the same as theirs, right? I think so. So we'll call number leaves on test tree. And is this last one? There's my 0, 1, there's my 2, there's my 3, 4. All right, is that the homework?
I think so, yeah.
How many of you got it? I hate all of you. All right, so first of all, we all recognize that was a 3-star, right? Do we, now after I just kind of explained it, again, I keep going through this pattern over and over and over again. Break it down into those tiny steps, right? You were probably, those of you who really struggle with it, trying to conceive of the entire problem at once, right? What did I need to know when I processed the arson? I needed to know where this guy left off. What does that mean? It means how many leaves did I find over here? Does that make sense? That was that last step. So I'm predicting that was the step missed. You probably figured out I need to know where this guy left off somehow, because that's where I pick up here. That next question needs to be, what does that mean? Because your obvious approach is to say, well, I'm going to somehow keep track of this. And then when I go and do this one, you probably could have pulled it off ghetto style, let's say, with like a set bang and a global variable or something like that. You know, just kind of keep a running total. Like, this is kind of the thing. I'm just gonna hide this number up there, and whenever I find a leaf, I'm gonna grab that and change it. Could have made it work that way. It would have been a little kind of janky, but it would have worked, right? But I'm predicting that most of you got to the point of recognizing the first part of this is easy. It's remembering where I left off for that second part. And then you missed asking that final question of what does that actually mean? Your mind went to, I need to keep track of it somehow, instead of saying, well, if the number is this, and I found 2 leaves up there, and the number is what it started up here plus 2, I only need to know how many leaves are up here. I didn't have to keep track of it. I just need to know the count. And I can write a function that counts leaves. Writing the function that counts leaves wasn't all that hard. Or at least it was in our wheelhouse. That was like a 1.5 star problem. Something like that. Right? Well, I mean, it wasn't trivial, but it wasn't quite 2-star worthy. But certainly count leaves was a lot easier than whatever the name of our function we just wrote, number leaves.
That was pretty easy.
Does that make sense? So then we come, kind of come full circle on this. What made that a 3-star problem? It's what I just explained. That skill had nothing to do with the programming. It had everything to do with the thinking. Asking that one extra question. And this goes back to 150. Before you can solve a problem, you have to understand it. Make sense? And this problem is purposely, and I think perfectly, designed to expose that weakness, because most of you don't necessarily have that weakness for a general problem. You kind of almost need to be slightly tricked, right? You got to stumble upon something that's not quite as obvious. So something like this, it almost kind of takes you down this, it's deceptive. Because it's lulling you into this idea of, oh, I got to keep track of this somehow. So then you put all your mental focus into that, right? And you could have pulled it off. You could have done, what I had kind of mentioned of, somehow returning a 2 list where the first element is your count and your second element is your actual new LSON. And then maybe with the let, kind of rip the pieces out and put them back together. It would have been complex to follow, but you could have pulled that off somehow, kind of just passing this thing through there. Okay, so questions on this one? Does it at least make more sense now that we've seen it? If you had to do it again, if I gave you another problem similar-ish to this, would you have more of a fighting chance? At least you'll challenge yourself to say, what does that mean? Okay. So, are there any 4 stars in here? That would be fun, wouldn't it? What? A 4-star? No. Well, okay, so out of curiosity, so let's ask that same question. How long did we spend on this one? 5 hours, and get it or not get it?
I just ran out of time.
Okay.
I spend a significant amount.
How many hours? Anybody have 5 beat?
Around that.
What's the average? Does 5 feel like averagey?
I would say between 4 and 5 at least for me.
4 and 5?
I'd threw some stuff together and kind of hoped it worked.
Okay, but didn't quite get there. Middle row? How much time? 90 minutes, and got it, didn't get it. Got it. Okay. Did you do it in a similar way to this, or did you do a set bang?
Yeah, I did it in a similar way to that. I was kind of turning over how do I count it and build it at the same time.
Okay.
As I was going throughout my day. Then I sat down to work on it and got that eureka of...
Okay, you finally asked that extra question.
Right.
Okay. What about over in this half? Did you get it, Jack?
Yeah,
How long did you spend on it?
45 minutes.
Like six seconds. Spent about 6 seconds on it. I got an arm cramp. All right, and did you do it similar?
I did the 2 list.
Oh, you did the 2 list, the pass around thing? So yeah, so Actually, 45 minutes for that isn't horrible because that guy's kind of hard to debug because you gotta peel out your pieces and make sure you're left because the debugging on that, you might sometimes have the right thing, but inside of a list that you didn't intend. So you have a list of a list. It's like, it's right there, but how do I get that out? Okay, so we'll call 45 an outlier. That's obvious, right? Okay, and even 90 is probably an outlier. Okay, and I mean, and those two folks are kind of like the weirder thinkers. So it's not really surprising that they stumbled upon, well, I mean, it's not unfair, is it? I mean, we all think in different ways. So, I mean, if you just, think, I mean, a Pell just kind of thinks funky. And that's okay because it's not surprising that he would stumble upon that eureka moment because he might be more willing to just jump outside of that box sooner or something just because it maybe looked fun. I mean, yeah, and that's okay. That's going to help him sometimes. That's going to take him down this rabbit hole other times. It's going to be like this infinite loop forever. Okay, what about over here?
I looked at it for about 2 hours, but I was tired and I fell asleep.
Okay, so didn't try. And what do we got over here?
2 hours.
2 hours and got it? Didn't get it?
I got it.
Got it, okay. And which approach?
I use this approach.
This approach, okay. Okay, so probably call that even a slight outlier. 2 hours is still pretty quick. So it sounds like the division here is somewhere in the ballpark of 4 to 5 hours where there was probably 3 hours of productivity and then 2 hours of not asking that question, banging your head on the wall. So people either made that turn and got it, or and probably got it relatively quickly after they made that turn, or they just kept banging on the wall until they just said, I'm done, which is okay. So now I'll give you a little bit of advice. Now I'm not encouraging you to cheat, but I want every assignment to be an instructional thing. So always, 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 always start off by trying to do it yourself. Okay. Now, V cheated off of me. But I happen to know she also started off working on it on her own for a long time and then said, okay, I kind of need a hint, right? This book's been used for 1,000 years. You could find solutions to these on the web. Now, don't do that. You're only cheating yourself for finding a solution just to submit it, right? What do I care what grade I end up giving you on the thing? I'm never going to see you again or something after, next 4 or 5 years. You're hurting yourself down in the future, right? But if you kind of hit that wall, you're at that 3 hours and you're just banging, 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 you're no longer making progress. It's no longer an instructional exercise. Peek. Look up the question, kind of say, try not to just study it too much. Just say, oh, I get what they're trying to do there. And then shield your eyes, right? Go back now with that little newfound knowledge and work on it a little bit more, hopefully to get you past that little wall. Does that make sense? That's where things like Google and things like that can be very instructive, all right? I think she went and watched my videos from 2 years ago, or something like that. But I mean, these things are all out there, okay? But whenever you're going to go and use an online resource like that, I mean, some of your other teachers might not be cool with that, but I want you to learn. So getting to the 3 hour mark and banging your head on the walls for another 2 hours isn't learning. Okay, that's concussing yourself. So once you're convinced that you're stuck, peek and try to look at the bare minimum that you have to look at to get you unstuck for the next little step. Right? Or ask in Slack and I'll, kind of show me your code. I'll give you the little push. It's like, well, have you thought about this? And sometimes it's just that little comment that will make you kind of think in the other direction. All right, does that make some sense? All right.
I can personally vouch for this method because this is what got me through linear algebra.
Yeah, because keep in mind what you're here for. You're paying a lot of money for your tuition to take 18 credits, multiple Littman coding classes, because they're easy, right?
Ask me about 10 years in
But that's just business, right? If you pay for something, you should get your money's worth out of it, replace college with whatever and say, you know, if you buy a cool gadget and it has 5 features, you should use all 5 features. Just because it was an expensive gadget.
Right. When you go to the cafe, you need to get 5 plates of food. Otherwise, you're cheating yourself.
Yeah, it says all you can eat. I don't know when I'm going to eat this, but I can eat it eventually. All right. So, yeah, whatever. You're spending a lot of money. You know, I'm not saying go insane, but take at least 18 credits. You can take more if you want. Huh?
$600 per credit after.
Oh, yeah, don't do that. 18's enough. 18's enough, and then work really hard in those 18 and then do some extra stuff. That way you're not bored. Blaine's just stewing in his head. I can just see it. Trust me, you're more capable of doing what I'm talking about right now while you're young and have energy than later on when you have these aspirations oh, I'm going to be able to stay up until 3 a.m. and work on this. And you get to midnight and your ears are ringing. You can't see straight. All right. So let's pop back up. So we're getting ready to bounce into what?
You said you're doing the search data tree thing.
I know. I just said we're going to bounce back up.
Oh,
I'm telling you I'm about to say what you're about to complain about. So where we're going now, starting next week, V, is we're going to start diving down into some of the early pieces of actually creating an interpreter for our language. Okay? But before we get there, we have one final 3-star. So let's talk. It is going to be homework, but let's talk about this for a few minutes. Okay? So this guy says, write a procedure called path. I know we mentioned this last class, but let's talk about it again. Write a procedure called path that takes an integer n as well as a binary search tree, BST. This is different than our bin tree that we've been using up to this point. So just real quick. Hold on. Is there a... Yeah, here it is. So binary search tree, it's on page 10 of this guy, I guess. So a binary search tree, here's the grammar for it. This grammar has 2 productions. This is the first production. This is the second production. So I'm kind of emphasizing those words because we're going to start using those more often as we start getting into more complex grammars for a language. Like you could have a grammar like this for the Java language. And I promise you there would be more than 2 things. Okay? So, we're going to be building more complex grammars. So, a binary search tree can either be an empty list or it can be a 3 list where the first element is an integer, the next element is a binary search tree, the last element is a binary search tree. Okay, so that's the generic grammar for a binary search tree. Now, what this grammar does not allow you to capture is the binary search tree rule that we know from data structures. And that is that everything to the left, everything inside of that binary search tree right there will be less than or equal to this number right here. Everything in this binary search tree right here will be greater than this number right there. That make sense? So even though you can build things that do match this grammar, that don't follow that rule, for the purpose of this assignment and logic that says, I know what a binary search tree is supposed to be, you can assume that people are passing your function accurate binary search trees. That is to say, they meet the requirements of this grammar, and everything in the left subtree will be less than or equal to this value. Everything in the right subtree will be greater than this value. That makes sense? You may, just may, find it handy to do some of those constructors and extractors and those types of things for kind of working with this. Just saying. All right, so let's go back to this guy and just make sure we understand what this function is asking us to do. So here's path. So it's going to take an integer n, the thing we're searching for, and a binary search tree that we just talked about. And this guy is going to contain an integer and returns a list of lefts and rights, GPS instructions. Do I look for my value in the left subtree, or do I look for my value in the right subtree? And we can only make those decisions based on knowing the value we're searching for relative to the value we're currently looking at. Am I less than or equal to this? Well, if I'm equal to this, I found it, right? Finito, done. If I'm less than this, I need to look at the left search tree. So left should be added to my running list of directions, my GPS directions. If it's greater than that, I should add a right to my running list of directions. All right, so in this case, if I'm looking for a 17 in this list, I first come in here and I see a 14. So a 17 is greater than a 14, so my first direction will be a right. All right, so then I'm going to be looking in the right subtree. I look at a 26. Is a 26, is a 17 greater than a 26? Well, a 17 is not equal to a 26. We haven't found it yet. Is it less than it? It is. So we'll look in the left subtree. Left. That'll be this guy right here. Is it a 20? No. Is a 17 less than a 20 or greater than a 20? It's less than a 20. So it would be my left subtree. I go into that subtree. Then I look at the value. I found it. I'm done. Make sense? So the directions for how to traverse this tree to find a 17 is check the right subtree, followed by the left subtree, followed by the left subtree. You're at it.
So what if they cannot find it within that tree?
Does it say, let's see, if n is found at the root, it returns the empty list. I guess if you run out of trees, you could probably just return false maybe, or if you want to return the list of all the directions as far as you got, but maybe you put a false at the very end. You can kind of decide how you want to handle not found, or you can just assume that it's found. In fact, that's probably for the purpose of the assignment. It's probably fair to get out of it what I want you to get out of it by just assume that the tree that you're searching has the number you're looking for in it. Go ahead.
Will it make any functional difference here if we use the symbol left and right or the string left or right?
Well, you would be, well, no, I don't think so. Not for this, because it's just a list of words.
Okay.
Yeah. So he's asking, can I just single quote it or can I put double quotes around it? It doesn't matter. It's just as long as it doesn't try to resolve to a variable, you're good.
Okay.
You could do L's and R's for all I care. You know, I'll figure it out. It'll be okay. All right, questions, comments, concerns, bribes. Go ahead.
Just a question on the binary tree.
Yep.
So I can visualize it. Let's say the number is 5.
Mm-hmm.
Is the left tree going to have 1, 2, 3, 4, 5, let's say, and then the right tree is going to have 6, 7, 8, 9, 10?
Well, it might not have all of those. All you know is the left tree will have values smaller than the root node of the tree you're looking at.
So looking at the example they give here, 26 is on the right,
26 is on the right subtree of this top level, which means all the values in that are going to be greater than 14. So this is your root node, 14.
Yeah.
Everything in the left subtree will be less than or equal to 14, as it is, 7 and a 12. Everything in the right subtree will be greater than 14. 26, 20, 17, 31, all greater than
So if I
14.
If I have 14 here and what's the second tree?
What's the what?
Like if I nab into, I'm trying to visualize it.
This is left subtree. This is right subtree. Left subtree, right subtree. But these are binary search trees in and of themselves. We look at this guy, we have a 7. Everything to the left of that 7 should be less than it. This is that subtree, there's nothing in there. Everything to the right of that will be greater than that. Here's the right subtree. We only see one thing in there, it's a 12, greater than 7. If we happen to look at just the right subtree down here in and of itself, we have a 26. Everything to the left subtree of that will be less than 26, or equal to. Everything to the right subtree of that will be greater than 26. We have a 31 there. This subtree, we have a 20. Everything to the left of that will be less than or equal to 20. We have a 17. Everything to the right of that would be greater than 20. In this case, there's nothing there. It's the empty list. That is the empty tree. So that is how binary search trees work. It's the rule for binary search trees. It's a tree that has a top node and then up to 2 children.
Yes.
0, 1, or 2 children. They're representing an empty child here as an empty list.
Which makes sense. I'm just trying to figure out why are you taking 2 binary trees?
You're not. You're not taking in 2 binary trees. Here's the number we're searching for and a binary tree.
Oh yeah, but like
That is a single binary tree. It just follows the pattern of a binary tree is either an empty list or it's a 3 list. A 3 list with a number, a binary tree, and a binary tree.
what do you do with the second binary tree?
That's the right child. Binary tree means 2.
I see.
So he has a left child and a right child. Left son, right son. Just happens to be, so this is pretty similar to what we've done in this last assignment, except we've replaced our labels, our contents of piece, with an actual number, and we've applied the binary search tree rule to it, which says stuff to the left is less than or equal to, stuff to the right is greater than. Make sense?
Yeah.
This is related to in 300 when we did the in order, post order stuff where we could go through, created a binary tree, and we walked through that tree and we said if we go through in order, we get the numbers in sorted order. If we go through in post order, we get them in a kind of a weird format, but it was kind of like, how do you traverse a tree? So if you go back and look at the notes, you'll find tree traversal stuff. That's kind of what we're talking about here. That makes sense?
Yeah.
What we're trying to accomplish? GPS instructions for finding a number in a binary search tree, and you can assume that the number will be found. All right.